Let me ask you something. What happens when your database becomes too big for a single server? You add more RAM, you upgrade the CPU, you buy a stronger machine. That works, but only for a while. Eventually, you hit a limit. And when that happens, you don't scale up anymore. You scale out. And that's where sharding comes in. Let's get started. Imagine you're building a global food delivery platform. Millions of users, millions of orders, constant payment transactions. Everything is stored in one database. As traffic increases, the database starts slowing down. Queries take longer, write compete for logs, indexes become massive. At some point, no single machine can handle it. So instead of storing everything in one place, we split the data across multiple databases. This is called horizontal sharding. Horizontal sharding means we split rows across different machines. For example, orders 1 to 5 million go to database A, orders 5 to 10 million go to database B, and orders 10 to 15 million go to database C. Each database has the same structure but different data. Now instead of one overloaded database, we have 3 small ones handling traffic in parallel. This improves scalability dramatically. Here's the real question. How do we decide which order goes to which shard? There are 2 common approaches. The first one is range-based partitioning. In range-based partitioning, we divide data based on value ranges. For example, orders from January to March go to shard 1, orders from April to June go to shard 2, and orders from July to September go to shard 3. It's simple, easy to understand, easy to debug, and makes the range queries fast. But there's a problem. What if most users are placing orders this month? That shard becomes overloaded. This creates what we call a hotspot. Range-based partitioning works well when traffic is evenly distributed, but real-world traffic is rarely balanced. So we move on to another strategy, hash-based partitioning. Instead of using ranges, we apply a hash function. For example, a shard number equals hash of order ID modulo number of shards. Now orders are distributed almost randomly across shards. This balances load much faster, much better. No single shard becomes a hotspot easily. But again, there's a trade-off. Range queries become harder because data is spread across shards. So choosing the right shard key is critical. It's the field you use to decide where the data goes. A poor shard key creates hotspots, while a good shard key distributes traffic evenly. For example, using a sequential order ID could overload one shard, while using a hashed user ID spreads traffic faster and better. Now, here's where things get tricky. Let's say you started with 4 shards. Your formula was hash of order ID modulo 4. Business grows, now you need 5 shards. Now your formula becomes hash modulo 5. Suddenly, almost every record needs to move to a different shard. This causes massive data reshuffling. Very expensive, very risky. So, how do we scale without moving everything? That's where consistent hashing comes in. Instead of directly mapping data to shard numbers, consistent hashing maps both data and shards onto circular hash space. Each shard owns a portion of that circle, so when you add a new shard, only a small portion of data moves to it, not everything. But not all sharding splits rows. Vertical sharding splits columns or tables. For example, user profiles to one shard while transaction history to another shard. This reduces load on each database and can improve performance for certain queries. But sharding introduces complexity. Joins across shards are harder. Transactions may need to span multiple databases. Example, getting all orders for a user may require querying several shards and merging results. So while sharding solves scalability, it comes with trade-offs in query complexity, consistency, and operational overhead. So to summarize, scale-up works temporarily while scale-out is the long-term solution. Horizontal sharding splits rows, vertical sharding splits tables or columns. Range-based partitioning is simple but can create hotspots. Hash-based partitioning balances load but makes queries harder. Consistent hashing and virtual nodes allow smooth scaling with minimal data movement. Choosing the right shard key is critical. Cross-shard queries and transactions add complexity. Sharding makes your database scalable but also requires careful planning. So in the next video, we'll talk about replication and fault-tolerant storage because distributing data is good, but making sure it never gets lost is even more important. Thank you for watching, and I'll see you in the next one.